All right, other clarifying questions? The bonus was that second project that you could do. You have to follow the directions precisely on that second one, but it's kind of nice how it ends up. Yeah. Since we did the state review, we'll skip this one. But it is things that we need to know in our lesson today. All right, the main part of our lesson today is we're going to talk about what a mid-segment is, and then hopefully have some time to explore these and work on projects a little bit. Let's talk about what a mid-segment is. It is a segment that joins the midpoints of two sides of the triangle. I think the notes begin like halfway through a page. Okay, got your notes down, got a sketch there. Okay, you see a space where you can construct a mid-segment? All right, so in that rectangle space with a straight edge, make a good-sized triangle. Maybe you want to make it obtuse and scaling-ish. And I want you to actually construct the mid-segment. So how would you use your compass to help you find the midpoint of two sides? Midpoint of two sides of your triangle, and then you're going to connect them. You've done part of your project where you've done perpendicular bisectors or medians. You've had to do constructions of midpoint just recently. Probably.
So we have to do it to two sides of the coin?
Yep. Find two midpoints. Okay, if anybody's stuck, your construction was from one end of the side and then from the other end of the side to the same arc. Those two will help you find where that midpoint is. Locate the midpoint, locate another midpoint, and then connect those two midpoints together. Okay, as you get it created, yes. You're doing the midpoint construction twice. Connect those two midpoints, making a mid-segment, which is probably a different orientation than quite a few, but you're doing the right thing. I love her. We're gonna do the same thing. I know my marks are bad, but you gotta get it to cross twice. Okay, quite a few of you have that finished. Now, as you look at the picture, what do you notice about the mid-segment related to the triangle? Okay, it divides it into a trapezoid and a triangle, it looks like. Is it what? Is it parallel to that side? To the base or one side, depending which way you did, because someone made it going this way. Looks like maybe it's parallel to a side of the triangle. Yes, it does. And it is. How long is it? Measure. How long is it?
Minus 2 inches.
Well, everybody's is gonna be different, so no reason shouting out your measurement. Write down what your measurement is. So how long is that? You can either do in inches or in metric. Okay, and then see how long the side that you think it's parallel to is.
It's gonna be
Are you getting the mid-segment to be half as long as that side of the triangle that it's parallel to? Just. If you do that correctly, it is. Like if this were 4 inches, then this one would be 2 inches. The mid-segment is half as long as the side that it's parallel to. Work out? Okay, those ideas, I think if you turn the page, are on the mid-segment theorem. The triangle mid-segment theorem. A mid-segment of a triangle is parallel to a side of the triangle and its length is half the length of that side. This theorem tells us 2 things about the mid-segment. It's parallel to a side of the triangle and it's half as long as that side. And we just investigated with it. We're actually going to work on proving it. What are some things that might come to your mind in relation to parallel lines and transversals? We've been doing that a lot. Things like alternate interior angles, corresponding angles, remember how they're in the same position? Alternate exterior angles, alternate interior angles. How about slopes? What's the relationship of the slope for 2 parallel lines? They are the same. So when we do some proving, we're going to be calculating some slope and see if the slopes are the same. Okay, so the theorem has 2 conclusions. That DE, the mid-segment, is parallel to the side of the triangle, AC, and that DE is half of AC's length. Right, so as far as workout kind of problems, anyone need the screen? Okay, it says find the length of the mid-segment and what angles are congruent. So how long is the mid-segment? 14 inches, correct. And what angles are congruent? Now how are you going to get angles congruent? It's based on the parallels. Angle R and angle T, no. You're just guessing things, huh?
Or listen
Angle S and T, depending which angle S, this angle S, and this angle T. Because with the parallel lines, those would be what kind of angles? Those are corresponding. They're not alternate interior, they're corresponding. Now you'd have to say angle RSM in order to name that one correctly. So those two will be the same degree measure.
So the angle N and angle M,
Give me 3 letters for the angle M.
what?
Which angle M?
Oh, R and M.
Correct. Those two angles will be the same also. And won't the angle R be the same whether you think about the small triangle or the big one? It's the same angle because of reflexive property idea. Okay, so let's go a little further. And we're going to do some calculations to prove the parallel and the half as much. You need to write this down. Yes, we're going to do the whole thing, and I think you're going to use that little graph piece that's there. Okay, so the vertices of triangle XYZ are listed there. M and N are the midpoints of segment XZ and YZ, which makes MN a midsegment. We're going to try and show what the theorem says. We're going to try and show that the midsegment is parallel to the side of the triangle, and we're going to try and show that the midsegment is half as long as that side. How are we going to show it? We need to demonstrate by calculating, kind of like a proof. And we're probably not going to write it with statements and reasons exactly like what you're thinking to column, but essentially that is what we're doing.
So mine is like,
Yeah, it's supposed to be on the top of X, yes. And I need to orient my screen probably because I'm writing not where I'm touching. I'm going to do that, but I don't know if I can right now. Yeah, get the 3 points and then graph. Got your 3 points listed? Show is kind of an informal way to say proof. Picture looks something like this. You should have a better picture than I do, but that type. Okay, I'm going to orient my screen so I can write better. Right, it says M and N are the midpoints of the segment. So you need to find the midpoints. Back, I think. All right, so I need to find, or you need to help me find, the coordinates of M and N. Okay, M, it says, is the midpoint of XZ. And then N is the midpoint of YZ. How do you find a midpoint? Well, you could construct it. Actually, we're going to do more calculating. How do you calculate a midsegment? Second formula down. Okay, so on your note-taking, you need to make it clear what you're finding. So write down that you're finding the midpoint of XZ. And is that M or is that N? XZ. So M. M is the midpoint of XZ. is -1 plus 3 divided by 2, and 8 plus -4 divided by 2. Which comes out to make him the 0.12. And graph that. Does that make sense? Is the 0.12 halfway on XZ? Then N is the midpoint of YZ. So use Y and Z. Y and Z. 9 plus 3 divided by 2. 2 plus -4 divided by 2. 6, -1. That's 0.8. So if we connect points M and N, we created one midsegment, right? Now what we're going to do is calculate to show that the theorem is supported. So we're kind of proving the theorem by just going through it with one example. I shouldn't say that we're proving it, we're demonstrating that it works. No, that's not all we have to do. How are we going to show that MN is parallel to XY? What can we calculate that would help us
Slope.
tell? Okay, slope. What do we need to find the slope of? XY and MN. Okay, so slope of XY, slope of MN. We're going to demonstrate that XY and MN, the midsegment and the side of the triangle, are parallel. How are we going to do that? They should have the same slope. Let's make sure it works out right. Slope, subtract the Y values for the numerator. Subtract the X values in the same order for the denominator. So I'm getting -3/5 when I reduce. Did I do that right? It's going down. MN, its slope. Subtract the Y parts for the numerator. Subtract the X's in the same order for the denominator. 3 over -5, so -3/5 for that also. Okay, so did we get the same slope? What's that mean then? Parallel, so let's say that. Okay. So since XY and MN have the same slope, XY is parallel to MN. Okay, so we showed that MN and XY are parallel. And we're supposed to show MN is half as long as XY. What would we calculate to show
Distance.
MN is half of XY? Distance formula, right? Okay, so distance. Okay, I need to find the distance, the length of MN, and then the length of XY. I'm thinking MN is going to end up half of XY. The distance formula now. Good practice on all our formulas. Square root of the X values subtracted, and the Y values subtracted. Oops, I'm not doing that. X values, 1 minus 6 squared. 2 minus -1 squared. Depends what you call the twos and what you call the ones. So I was calling these the twos and these the ones. Am I using the right ones? Yeah. These the twos and these the ones. If you wanna call these the ones and these the twos, fine. We'll end up with the same answer. Alright, so I'm getting square root of negative 5 squared and 3 squared. Gotta square and add before you square root. Order of operations here. So 25 plus 9. We're at 34.
Yeah.
Can we simplify that? 2 times 17, 17 is prime. I don't think I can simplify that at all. So square root of 34. Okay, now let's try xy. X and y are the 2 points. Gotta make sure I'm using the right points. Negative 1 minus 9 squared. 8 minus 2 squared. Negative 10 squared and 6 squared. Like 100 plus 36. Still have to do the square root of all that. Can I do a factoring tree on 136? I can divide 136 by. At least 2 I know. 2 and 68. 68 would be 2 and 34. 34 is 2 and 17. So how do I simplify that? There's a pair of 2's that goes out. There's a 2 and a 17 that don't pair up, so they can't be simplified. So 2 times 17 is back to 34. So how do our lengths? Square root of 34 and 2 times the square root of 34. This one would be half of that one. So let's finish this part with a sentence. Okay. Since square root of 34 equals 1/2 of 2 square roots of 34, we have mn equaling 1/2 of xy. That came out of our calculations. So if we did it right, slopes were the same. That got us parallels. Distances simplified to one of them being half of the other. So all of that, here's a summary of the steps. And I think this has different numbers in it. I don't know if we need to do a second equation or not. So what are the steps? Why don't you write down the steps that you need to do? Because you've got to do one of those on your homework. And I don't want to come back with that being the question tomorrow. So first step is to graph the triangle. I don't know if you want to say RST, but graph the triangle. Step 2, find the coordinates of the midpoints. Pay attention to which side you're finding the midpoint of. So pay attention to which sides. Like as you read through this one, it says M's the midpoint of RT. So find the midpoint of RT. N is the midpoint of segment ST. My segment symbols have gone wild. I need to clean those up. Step 3. Find the slope of the midsegment. This is the midsegment. And this is the side of the triangle. Find the slopes to see if they're parallel. What should happen? The slopes should be equal. If the slopes are not equal, something's going wrong. Either your midpoint's wrong, or you're using the wrong sides, something like that. So that would get you the parallel part. And then the last step is to find the length of the midsegment and the triangle side. And this is the midsegment. This is the triangle side. Distance formula. And again, if you're doing it right, notice how that's simplified to one of them being 2 times the other one. That's how it should come out if you're doing it right. Understand the process, thumbs up or down. Understand what that problem will involve? Did you take notes on it? Yeah? Okay, if you're not showing me, I don't know what's going on. Does that mean you're not going to do it? You got it? Okay. I was looking for a signal. All right. Anyone still need that screen? Okay, I'll wait just a little bit. What are the 2 things that midsegment theorem tells us about the midsegment? 2 things. Read that theorem again. 2 things about the midsegment. It's half the length of the side that it's related to. I'll say that. And it's parallel to that side. So you'll be asked some angle measurements probably, and you'll be asked some side measurements. Okay, while people are finishing this one, can you sketch a triangle? And we've been looking at 3, like altitude, 3 median, 3 perpendicular bisectors. Can you put the 3 median, or did I say the wrong one? Midsegment. Put the 3 midsegments in a triangle. Just kind of sketching it, you don't have to construct it. Estimate where your midpoints are on each side. Draw the 3 midsegments in for one triangle. And let's see what happens with them. Yeah, make all 3 midsegments. What's a midsegment? Midsegment connects 2 midpoints. So connect 2 midpoints. That's not a midpoint. Connect those 2 midpoints. Connect another 2 midpoints. That's one of them. I would say this is the midpoint. Okay, are these 3 midsegments concurrent? What's that word mean? Concurrent. Are the 3 midsegments concurrent? Look back if you don't remember. It's defined in your notes there somewhere. What's concurrent mean? Yeah, if the 3 lines intersect at one point. So do the 3 midsegments connect at one point? Are your pictures looking like this? Something like that? Okay. So do all those midsegments come together at one point? No. Midsegments are not concurrent, but they make a cute little triangle. That little triangle is called a midsegment triangle. I don't know if my notes are ready for that or not. Yep. Midsegment triangle. I think there's a place in your notes to draw that. Put that, that's your definition over there somewhere. Midsegment triangle. So that mid-segment triangle actually is pretty interesting if you look at measurements and so forth. Done with the notes about it? Okay, so let's do an example that has the mid-segment triangle in it. It says find the length of BD. How long is this side?
Half of 17.
Half of 17, which is? Half of 16 would be
8.
8, so 8.5. You're doubling it.
Yeah, it's
You need to go half of it instead.
Yeah.
Okay? How about angle CBD? CBD, how many degrees is this angle? That angle you might be saying is the same as this one?
Yeah.
I would agree. Keep going. Yeah, turn. There's another parallel involved.
No.
No? If I highlight this side parallel to this one, and this transversal, you see the 26 degree, and this one would be alternate interior. So the angle I'm after is 26. Angle A is 26. There's one more angle in here that's 26. DFE is 26. It would be like alternate interior to that one, or it would be corresponding with that one. Okay. All right, let's keep going. I'm going to get another angle in here. This looks like about 100 degrees. Okay, what other angles are 100? Page? Which angle B? BFD is down here. That one you think is 100? AFB? AFD. This whole thing is 154?
Yeah.
Okay, I agree. I'm looking for a 100-degree angle.
Oh, would that be BF?
Parallel lines and transversals? BFE? I don't know that I can get there. BFD? Okay, I'm asking, what's your support?
Looks right.
Okay, looks isn't a good thing. The angle you're picking out is going to be 100, but I don't think right now you can support it. How can we get to that spot? Well, this 100 corresponds with that 100. Parallel lines, transversal, corresponding angles. Now I could do alternate interior to get to the one you wanted. And I could even go over here corresponding. In green, you said this one's going to be 54. Corresponding, 54. Corresponding, 54. Let's see, there's one more. Your alternate interior, 54. I know I've got a lot of scribbles in there, but you notice those triangles all have the same angles? And they have at least one side congruent. All the little triangles in there are identical. The middle one's kind of flipped over. You have 4 little congruent triangles. What side lengths? Let's see, this was 17. Wouldn't this part be 8.5? I think I'll write in black for the sides. 8.5, 8.5, mid-segment 8.5. 2 tick marks, 2 tick marks. This one would be the same. 3 tick marks, the mid-segment's the same. If you see the sides, each one of them has a 1, 2, 3 tick mark. 1, 2, 3, flipped over, 1, 2, 3. Side, side congruence. There is a side, similarity that we'll eventually get to, but not congruence. All right, so I've got a bunch of things in there. I just wanted to point out that mid-segment triangle is kind of interesting. It's the same size as the others.
Is that in the test or the quiz?
I will probably not ask you all that at one time, but I might ask you, like this is saying, find angles CBD. Okay, parallel lines, transversal. So I blew you away by putting too much up there.
Yeah.
Yeah.
I got lost.
All right, let's try just one thing. Can you find just JL? Is JL an angle or a segment? Segment. Is it a mid-segment or a side of the triangle? Side of the triangle. Which mid-segment's it related to? PN. Okay, so if PN's a length of 36, JL is 72. Twice as much. Okay. All right. How about PM? PM is going to be half of 97. Correct. 48 and a half. Okay, how about angle MLK? How many degrees is this angle? Why is it 102? Some of you are just kind of guessing, I think. Parallel lines, transversal, corresponding angles that are congruent. Is it better if we just do one at a time? All right, and a story type problem. If the distance of PQ is 46 inches, what's the length of support T if S and T are midpoints of the sides? PQ is 46 inches. What's the length of ST if this is a midpoint and this is a midpoint? What's ST called? Mid-segment. Half as long, so 23. All right. Okay. I think let's get some working time. Some of you needed to ask some questions on projects. I do want to mention this problem. Is n plus 14 going to equal 3n plus 12? No. So how would you figure it out? Okay, you could do n plus 14 times 2 or plus n plus 14 equals 3n plus 12. Right. So set it equal in the right way. All right. Let's get a little bit of time in case you need to ask some more questions on the project. 304. Are those optional? No, these are optional.
Wait, which ones are optional?
If you count up how many problems this is, it's not that bad. Quiz problems, we do have quiz tomorrow. You are allowed to make a note card and use that. I would look through the problems. 1 through 12 to remind yourself what the diagrams could look like on your quiz. So some of those pages obviously go back to some previous material from yesterday. It's not all today's mid-segment. So if you needed me to look at your project, let's grab that quick and take a look.